Hey everyone, in this lecture we are going to look at the continuous uniform distribution or rectangular distribution. The uniform or rectangular distribution has random variable x restricted to a finite interval ab. The square brackets represent a closed interval where a and b are included, and f of x has constant density over the interval. The probability density function for a continuous random variable distributed uniformly in the range x lies between a and b inclusive is, so the PDF of this distribution is 1 over b minus a and 0 otherwise. You can see an illustration of this distribution where we have the interval AB and a constant density 1 over b minus a, where a and b are the parameters of the distribution. From the diagram, we can see that the total area is 1. That is, the shaded area is 1. Let's see whether the area is indeed 1. So we have the length. Length is b minus a, and the width is 1 over b minus a. So the area is going to be b minus a multiplied by 1 over b minus a, and we indeed get 1. So this PDF is uniformly distributed in the range a, b. The expectation and variance of the distribution. The expectation is given by b plus a over 2, and the variance is given by b minus a to the square over 12. And the distribution is represented as x follows UAB or x follows unif AB. So this model represents the uniform distribution, the continuous uniform distribution with parameters a and b. So let's work out a few questions. We have a first question. X is distributed uniformly where x lies between 6 and 9. Find a probability, find the expectation, find the variance. So we know that a is 6, b is 9. Let's see how we answer these questions. We have been given a, which is 6, and then b, which is 9. We can find the function f of x, which is 1 over b minus a. So 1 over 9 minus 6, we have 1 over 3. Let's sketch the diagram. We have something like this. So this is x, f of x. A is given by 6, b is given by 9, and then the f of x is 1 over 3. The constant density is 1 over 3. You're asked to find the probability of x lies between 7.2 and 8.4. We need to find this probability. So this is what? 7.2, 8.4. Now we need to find this shaded area. This is a rectangle. To find the area, we simply take what? The length times the width. So we take this probability is going to be the length, which is 8.4. You minus 7.2. You multiply by the width, which is 1 over 3. We simplify. We have 1.2 multiplied by 1.3, we have 0.4. So the probability that x lies between 7.2 and 8.4 is 0.4. Next, you're asked to find the expectation. We know that the formula for finding expectation is to b plus a over 2. We know the value of b, which is 9, plus a, which is 6. We divide by 2. we have the expectation 7.5. The variance of x is given by the formula b minus a to the square we divide by 12. We know that b is 9, we minus 6 to the square we divide by 12. We simplify 0.75. Next question. The current in milliampere measured in a piece of copper wire is known to follow a uniform distribution over the interval 0-25. Part 1. Write down the formula for the probability density function f of x of the random variable x representing the current. Part 2. Calculate the mean and variance of this distribution. So from the question, we have a uniform distribution over the interval 0-25, which means we have a continuous uniform distribution or simply a rectangular distribution. We need to find the probability density function, the PDF, of this variable. We start the question by, over the interval 0-25, the PDF f of x is given by f of x is 1 over b, which is 25 minus a, which is 0. With interval x lies between 0 and 25. Here we have 0. Otherwise, the PDF of f of x is equal to 1 over 25. So we have the PDF f of x. Part B, you're asked to find the mean and variance. Using formula, we have the expectation of x, 25 plus 0, we divide by 2. We have 12.5 milliampere. The variance is given by b, which is 25 minus 0 to the square. We divide by 12. We have 52.08 milliampere to the square.